In today's video, we take you inside the recycling operation and the complete dismantling and rebirth of thousands of Aston Martin Valkyrie hypercars.
Welcome to Factory Founder, where we turn industrial chaos into manufacturing gold.
In the heart of an industrial wasteland, under the blinding glare of a relentless sun, lies a graveyard of ambition, not of men, but of machines. Thousands of Aston Martin Valkyries, hypercars born from Formula One engineering, each a masterpiece of carbon fiber, titanium, and raw V12 fury, now lie scattered in a chaotic labyrinth of twisted metal and shattered composites. These are not museum pieces. They are the severely damaged remnants of a fleet that has reached the end of its road. But this is not the end. This is the beginning of a remarkable transformation, an industrial odyssey where the very essence of these mechanical marvels will be stripped, shredded, melted, and reborn. The first step in this monumental undertaking begins not with a roar, but with a careful whisper. Teams of technicians in high-visibility suits descend upon the wounded Valkyries, their mission twofold: recovery and safety. Every drop of hazardous fluid, engine oil, coolant, brake fluid, is meticulously drained and collected.
Transmission fluid container is almost at capacity. Yeah, copy that. Shutting down the pump now. Prep the next barrel for the engine oil waste.
High-voltage battery packs, silent powerhouses of the hybrid system, are carefully extracted with specialized cranes, destined for their own recycling pathway. We see the pyrotechnic disarming team in action, neutralizing airbag modules and seatbelt pretensioners with controlled precision. The hypercars, once symbols of speed, are now rendered inert, their internal hazards neutralized, preparing them for the brutal dismantling to come. The gentle work is over. The heavy machinery moves in. Massive hydraulic excavators, fitted with powerful shears, bite into carbon fiber monocoques with a sound like shattering glass. The iconic V12 engine, the screaming heart of the Valkyrie, is torn from its mounts and hoisted skyward by overhead cranes. Transmissions, subframes, and suspension assemblies follow, each component ripped from the hypercar's skeleton. This is the brutal archaeology of dismantling, where every part is extracted and sorted. The stripped monocoque shell, once the pride of engineering, is all that remains, a hollow testament to the violence of the process. The Valkyrie is being torn apart, piece by piece, its components given a new identity as raw material.
Are we sure the transmission fluid is fully drained from this bay? Checked it twice. It's good to go.
The stripped carbon fiber shells enter the jaws of the beast. Massive industrial shredders, their hardened steel teeth spinning at immense speed, consume the Valkyrie remnants whole. The hypercar, so meticulously designed, is reduced to fist-sized fragments in seconds. Carbon fiber, aluminum honeycomb, residual steel, and copper wiring are churned into a single chaotic stream. The material cascades from the shredders onto vibrating screens, separating by size before moving to the next stage. The Valkyrie has now lost its identity entirely, becoming nothing more than a mixed flow of valuable components, ready to be unlocked. The science of separation begins. The mixed stream travels along high-speed conveyor belts beneath powerful overband magnets. Ferrous metals, steel remnants of chassis reinforcements and drivetrain components leak from the flow, clinging to the magnet like iron filings before dropping into collection bins. The remaining non-ferrous materials enter the eddy current separator, where a rapidly rotating magnetic rotor repels aluminum, copper, and titanium fragments, flinging them sideways into separate chutes. The hypercar's exotic materials are now divided: steel in one bin, aluminum and copper in another. We turn to the non-metallic bounty. The carbon fiber body panels, once the envy of aerodynamicists, are fed into pyrolysis furnaces, where extreme heat burns away the resin, leaving behind pure, recovered carbon fibers. Nearby, optical sorters use near-infrared light to identify different plastic polymers, PP, PE, ABS, from the hypercar's interior and exterior, separating them with precision air jets. We see the tire processing line, where liquid nitrogen freezes the rubber before it is shattered into fine crumb. Glass windshields are crushed into cullet, and copper wiring harnesses are granulated, stripping insulation to yield pure copper granules. Every non-metal component is finding its path to recovery. We enter the furnace hall. The recovered steel from thousands of Valkyries is fed into an electric arc furnace. Massive carbon electrodes descend, and blinding arcs of lightning flash across the scrap, heating it to 1600 degrees Celsius. The steel glows orange, then white as it liquefies. The molten steel is poured into a ladle, where alloying agents like manganese and chromium are added. This is the alchemy of industry, transforming hypercar scrap into high-grade steel ready for new construction and automotive applications. The molten metal is then cast into continuous billets, glowing as they emerge, before being cut and stacked, ready for a new life. The spotlight shifts to non-ferrous metals. Aluminum from the Valkyrie's chassis is melted in induction furnaces at 660 degrees Celsius, alloyed with magnesium and silicon, and cast into pristine ingots. The titanium, once forming the Valkyrie's exhaust system, is melted in a vacuum arc furnace to prevent contamination, then cast into high-value billets. We see copper from the wiring harnesses melted and cast into wire rod. The bright industrial lighting reflects off these newly formed metals, gleaming with potential. We witness the crown jewels of the process: specialty material recovery. Catalytic converters from thousands of Valkyries are processed through chemical leaching, yielding platinum, palladium, and rhodium, metals worth more than gold by weight. Rare earth magnets from the electric motors are demagnetized and dissolved in acid, their neodymium and dysprosium extracted. Circuit boards and ECUs are shredded and processed, yielding gold and silver. Carbon fiber composites, still valuable, are recovered through advanced pyrolysis. These rare and precious materials, salvaged from the Hypercar's most advanced systems, are now concentrated in sealed containers, ready to re-enter the supply chain for aerospace, electronics, and green technology. We arrive at the final sorting and packaging yard. The recovered materials, steel bales, aluminum ingots, plastic bales, rubber crumb, glass cullet, and sealed containers of precious metals are organized and prepared for dispatch. Hydraulic presses compress the ferrous and non-ferrous metals into dense, transportable bales. The materials are loaded onto trucks and cargo ships. The cleanup begins. Magnetic sweepers traverse the empty scrapyard, collecting residual fragments. Environmental inspectors test soil and water, ensuring the site is pristine. The final trucks roll out carrying the essence of thousands of Valkyries to smelters, refineries, and manufacturers around the world. What began as a graveyard has been reborn as a treasure trove. The Aston Martin Valkyrie, in its death, has given life to new steel, new aluminum, new titanium, new copper, new carbon fiber, new plastic, and even new precious metals. Every component of these hypercars has been accounted for, recycled, and transformed. This is the circular economy in action, a future where waste is simply a resource waiting to be rediscovered, technologies yet to be imagined.